Hello everybody, in this video I'll cover how to render text into a frame buffer. So we have some character or some string of characters and we want to convert that into actual pixels in our frame buffer so we can display it on screen, or we can render into some offline render target. Now I'm going to be referencing some material that I've already covered in my recent video about bitmaps, so if you want to check it out you can click on the link in the description below. Okay, so unfortunately, or fortunately, there used to be a very straightforward of drawing text on the screen, because there used to be only one font, or only one way of doing that way back in the heydays of computing. Nowadays, there's all kinds of ways of drawing text. So we'll say that we have some kind of black box that's representation of a font. That could be vector graphics. It could be like a bitmap. The bitmap could have transparency or not have transparency. It could have color or grayscale, or it can be an even more packed representation than that. In any case, we're gonna want to draw into some rectangular area in our bitmap. And that rectangle is gonna have some width and height that we're gonna know in advance. That's gonna be coordinated with the definition in the font representation, so we know exactly how many pixels high and how many pixels wide our characters are going to be, both in the font representation and on the frame buffer. So say we have this character and we want to draw one portion of it in our frame buffer in some particular pixel and with some particular coordinates. We can have the coordinates be relative to that rectangular, so it'll be in the coordinate system of the font representation itself. And we want to be able to ask whatever's representing the font, should we draw a pixel here or not? Now, if the font representation supports transparency, we can ask more involved questions like how much should we draw in here, and what color should we draw if it's a colored font. But in this in this presentation, I'm just gonna use a very simple version of a font representation, and for a simple version of text rendering, whereby we just ask a question, a Boolean question, should we fill this pixel or not, basically, and we decide which color we put there when we're drawing, so we can draw text in any color. So in a sense, the font representation, we're assuming it's going to be not have any transparency or any gradients around the edges of the characters. It's just going to be a yes/no question: should we put a pixel here or not? Okay, so in our frame buffer, in terms of drawing pixels, we're gonna be thinking of the coordinates of the screen, the coordinates in our frame buffer in terms of some offset. If you haven't watched already my video of frame buffer layouts, it's typical that the memory representation of a frame buffer is linear with a one-dimensional array, so we just have some offset into the frame buffer, some index, one-dimensional number. And we're assuming that we're going to have some procedure that we can call that says, given that offset into a frame buffer with a particular color, set that pixel to that color. Okay, so we have this black box. There's can be all kinds of font representations, but let's have a closer look at one example of representing text font. So we could have just a bitmap in terms of actual bits. So in this case, it's going to be like a 6x8 grid of bits, basically. Internally in memory, it could be represented just as one continuous array of bits or of booleans or some other just number that includes all those bits in it. So this is 6 by 8, and we have the letter A, if you can see, and then we have the letter B, and in practice all the letters are gonna be in one continuous array, so it goes left to right, then down, left to right, down, left to right, etc. So it's one one-dimensional array in practice when we query it or ask it questions. So we have this procedure that we need to implement that just gives us a character and some x and y coordinates that are relative to within the rectangle that represents a specific character. And if you know the ASCII table, we know that if we're representing just letters, say, well, the first letter A has an ASCII code of 65, so if we pass the character A, we're actually being passed an unsigned integer with a value of 65. So that would be A. And what we want to return is basically font. In this case will just be the array that includes all the data, and we want to index into it with a particular offset, in particular index. So we can start off by just saying, okay, it's going to be whatever we got in the char minus 65. That'll start us off in wherever A is, and then we go on from there. So if we got A, we'll have 65 minus 65, which is 0, which is the first bit in our representation of A in this case. But then we need to have that 65 minus 65, the char minus 65, be multiplied by however many bits we have representing a single character, such that if we get the character B, we want to be skipping into into our array that includes all the character glyphs by basically one time in this case, which is the 66, which represents B, times however many bits we need to go from one character to another. Additionally to that, we need to then further push it down because we're getting also an x and y within that character. So say we got a 5 for y, then we have to go further down 5 times however many bits represent in a row of bits that represent the character, and then we also need to add the x, which will push us further down, so further in. So we'll say we got a 4, we end up with this bit, and in this case it will be true. Okay, so this is how our procedure is going to end up looking like. It's very simple. Let's get back to it. So we want to be able to draw a full character now, not just one pixel with this procedure. So let's see how that goes. So we're starting off with the frame buffer, and we have some offset already that is provided to us, so for where we want to draw the character, and we already know what rectangle we're expecting it to fill in. So we start looping over the rows that we know that exist in our font representation, looping over the height, and then within each row we loop over all the columns within the font width. And then we ask the question, should we draw a pixel here? In this case the answer is no, so we just skip that, and then the coordinates of x and y is going to be updating appropriately, but we also have our offset. In this case I'm assuming that the offset has been passed by value, so we can just update it in here. So we just increment it because we do need to keep it in sync with the way we're iterating over the input data from our font representation. So we just go there, and in this case it should give us true, so we end up setting the pixel in that whatever our current offset is with the color that we've been passed, and then going on. And then when we reach the end of the first row, well, the next iteration is going to be proper for the x and y coordinates of our font, but our frame buffer doesn't actually know how wide, like where it should go. So initially it's just going to go there, and then we need to move from here to where we want to be. So the first thing that we can do is just drop a full line of pixels down. That's easy. We just add to the offset the width of the frame buffer as opposed to the width of the font. That gets us too far though, so we need to move back by the amount of font width worth of pixels. That gets us to the offset that we want. And so the width minus the font width, then now depending on whether we want the font width to be constant or not, or we want to be able to query a representation of a font with a different width at different times. But regardless, while we're drawing one single character, these things are not going to change, so it's going to be constant for at least the duration of this procedure call. So we could decide to just extract, lift it up out of the for loops and just set it like that. And furthermore, if we want to really optimize it and we know that things are even more constant, we can expect it to be passed in from outside, and we just increment with that. Okay, so this is how to draw a single character. Now, how do we draw a full text, full string worth of text with new lines and spaces, etc.? So say we start off again with our frame buffer and a particular offset into it, and in particular we want to draw in starting from a particular position within our frame buffer in terms of pixels. And we're giving a string of characters in this case, and again a color. So we have a draw procedure, so we're going to start off initializing a position that's going to track the x and y position of where we're currently drawing into. It's going to be initialized at first with where we want to start drawing from. We also need to initialize an offset that we're going to be tracking into the frame buffer. When we do that, we just starting off with whatever x value, so we're pushing it in, and then going down however many pixels worth of a width worth of pixels for the frame buffer width, times the number of rows we're expecting to go down. Then we start looping over the characters in the string. First we need to check if this is a valid character that we actually want to draw, and it's not like a space or a new line. Then we call our draw character, and that we saw how it works already. So we're drawing a single character, and then we need to jump to the next place in the frame buffer that we want to draw the next character. So how do we do that? Well, we can increment our current position by offsetting it with the font width, so we can know where the next x position is, and we need to do the same for the offset. And we can do the same for the next character, and so on. But what if the next character isn't an alphanumeric character? Maybe it's a new line, maybe it's a space, but let's say it's a new line. If it's a space, we already know, we just do this thing that we're seeing here. I'm not showing it, but just increment the offsets without actually drawing. If it's a new line, we need to do something a bit more involved. So we want to draw the next character after the new line at the same level that vertically that we were told to draw our text in. So, but we need to drop one line of text below that. So we need to compute the position and the offset accordingly. So position is easy. We just set the position x with the x coordinate, the original x coordinate that we received. For the y, we increment it by the line height. No, the line height is usually like the font height plus some padding. So it's not exactly font height because we do want to have some space there. So in this case, it's going to be 1 pixels worth of space. And then incrementing the offsets is going to be a little bit more involved. So to get from here to here, first we can just drop just straight down. That's easy. That's just line heights worth of frame buffer width worth of pixels. In terms of offset, that gets us there, but that's overshooting, so we need to go back. So we can go back by whatever our current position x is. That gets us all the way reset to the beginning of the pixel line, the current pixel line. That's again overshoot, so we then add back what the x was, where we need to start drawing from what we got out in the call. Okay, so that's how to get the offset. Now there's a little bit of a bug here because we're assuming in the last line that position x is where our current position was, but we have just reset it 2 lines before. So to fix that, we just flip the order of those 9, and that is it. That's how we can draw text, a string of text with new lines using some font representation into frame buffer or a bitmap. That's it. Hope you enjoyed. If you did, hit the like button. If you want to be notified for further videos like that, you can subscribe. That's it. Thank you.